Blink and you'll miss it. On one awful week, the entire town of Chaiten was evacuated, all because of an unexpected eruption from the nearby volcano. I'm Julie Smith.
I'm Lou Lona. And I'm Philip Stevenson. That story and Peter Harvey's mailbag now on 6 to 8 minutes. On the 2nd of May, the seemingly dormant volcano of Chaiten erupted. Located 10 kilometers southeast of the town of Chaiten, it spewed ash into the atmosphere which spread across much of South America. This ash settled, covering nearby areas in a thick blanket, up to 30 centimeters deep in some areas. The local government immediately evacuated Chaiten, and by the next day the entire town was empty. This ash, while providing many minerals that help in the production of fertile soil, can also be very devastating when released in large amounts, such as in this case. Large amounts of volcanic ash can smother crops and block important transport routes. It'll take a long time for the ash in the surrounding areas to be washed away before the area can revegetate. On top of these problems, it also allows for the possibility of lahars to occur. Lahars occur when ash from the volcano mixes with rain to cause a devastating mudslide. As it travels, it picks up debris and mud, making it more lethal. They can cause extensive structure damage and cause harm to people. A lahar flooded the Blanco River on May 12th, carving a new path for the river straight through the town of Chaiten, causing a significant amount of damage. As well as this, the Chaiten volcano released another devastating blow to the surrounding areas: pyroclastic flows. Pyroclastic flows are flows of fast-moving, highly heated gas and rock, and are highly destructive, demolishing and incinerating everything in its path. The Chaiten volcano is located in southern Chile, which is on the border of two tectonic plates, the Antarctic and the South American plate. The Antarctic plate is colliding with the South American plate. This is called a convergent boundary. The Antarctic plate is less dense than the South American plate. This results in the Antarctic plate slipping under the South American plate. This is called a subduction zone. As the Antarctic plate slips under the South American plate, the plate melts and forms a greater amount of magma. This increased magma results in an increase in pressure. This pressure needs to be released, and once the pressure becomes too high, it forces its way to the surface in the form of a volcano, like the one in Chaiten. The Chaiten volcano was a rhyolitic caldera. Sulfur dioxide is an aerosol which reflects the sun's rays. If enough sulfur is released into the atmosphere, it can result in the Earth's climate being cooled significantly. Although some sulfur dioxide has been released from Chaiten, not enough has been released to affect the Earth's temperature. The last eruption of the Chaiten volcano was about 9 to 10,000 years ago. It is unsure why the volcano has remained dormant for so many years, or why it so suddenly decided to erupt again. The most probable reason for this is an increase in pressure in the magma below, and this caused it to erupt. The probability of another volcanic eruption occurring around this area is highly likely. This is because the west coast of South America, where it is located, as mentioned before, is on a subduction zone, where many volcanoes form. The Chaiten volcano is still erupting as we speak. Once it stops, because of its location, it is most likely going to erupt again. If this eruption was predicted before it took place, many preventative measures could have been put in place that would have lessened the amount of damage caused by this eruption. There is a range of different technologies around that can predict a volcanic eruption. One technology is the seismometer. This instrument is a weight suspended from a spring. Any movement of the weight is recorded either manually using a pen attached to the weight on paper or digitally using electronic impulses sent to a computer. If properly monitored, any vertical movements of the Earth can be seen. There is usually some ground movement associated with an eruption. Another technology used to predict an eruption is a tiltmeter. This device measures the horizontal level of the ground using small sensors to measure any change in the position of a small bubble in water, much like a builder's level. These, similar to seismometers, can be used to detect the movement of the ground associated with an eruption. Air temperature and water levels can also be used to predict when an eruption is imminent. Before an eruption, some gases and other materials are released. This can affect the temperature of the surrounding area by blocking or trapping heat from the sun. Also, water level can be altered. If these are recorded regularly, any changes could mean a volcano is about to erupt. These technologies, if implemented properly, would give the surrounding areas more warning if a volcano is going to erupt. This would give them more time to set up any precautionary actions to minimize the effect of the disaster, or conduct evacuations if necessary. One precautionary method which was executed quite well in this situation was evacuation. As soon as the eruption was realized, the evacuation started, and in about one day, the 4,000 people that lived in Chaiten were safely evacuated, except for one man who sadly died while traveling on a boat out of Chaiten. If the eruption was predicted before it happened, people would have more time to secure their property, and this one death may have been prevented. Another action that could be implemented is constructing channels to direct lahars away from any major infrastructure. This would prevent events similar to the one in Chaiten, as mentioned before, when a lahar demolished its way through the center of the town, causing a large amount of damage. Moving the town away from the volcano would also be a very effective way of preventing damage or loss of life. The problem is that there would be a high cost involved in executing this project. That concludes our story. I'm Philip Stevenson, reporting from 6 to 8 minutes, and here is Peter Harvey's mailbag.